Hi guys, in this lecture we will be starting with the study of calculus. So when we talk about calculus, calculus is also like algebra. In algebra what we studied different operations on number. Similarly in calculus we study different operations on functions. So basically there are two branches of calculus. One is known as the differential calculus, other is known as the integral calculus. But both branches have one thing in common, that is they talk about what kind of operations are you performing on a function. So it is very necessary that I have a good understanding of function before I proceed on to the study of calculus. So let us first talk about function. What is meant by function? There are two types of quantities. One is known as variable, other is known as constant. Now what is a variable? A variable which is usually represented by a letter like x, y, z can take on different values. That is, its value is not fixed. Whereas constant like 1, 2, 10, 50, it has a fixed value. Okay. Now in case of variable we define two kind of variable. One is known as the independent variable and other is known as dependent variable. Okay. Now what is meant by independent variable? That its value is not dependent on any other variable. That is, if I say x equal to 10, then that means the value of x is 10 and it does not depend on the values of y and z. Is it fine? But if there is some dependent variable, then its value depends on another variable. Suppose I say y is equal to x square, then the value of y when x is 10 will be 10 square, that is 100. So the value of y depends on the value of x. Here y will be called as dependent variable, whereas x is my independent variable. Now when we talk about functions, basically a function is a mapping between an independent variable and a dependent variable. Like the example that I just took, it is called to be a square function. Okay. So it is mapping an independent variable to a dependent variable. Now usually the range of the values of independent variable is known as domain of the function. Okay. And the range of dependent variable is known as range. So a function is basically a mapping between domain and range, or you can say it is a mapping between independent and the dependent variable. So let us understand the meaning of domain and the range. Basically domain is related to the independent variable. It is the set of values that an independent variable can assume. Let me take an example. Suppose I take 1 by x. Then x can take any value. Suppose this is y. Then x can take any value except 0. Okay. Why? Because at x equal to 0, this value will be undefined. So what will be my domain? Domain will be the set of real number minus 0. So that is what is meant by domain. Domain is the set of all possible values of an independent variable for which my function is defined. Now similarly if we take, let us say y is equal to cosec x, then it is actually equal to 1 by sin x. It will not be defined at the point where sin x goes to 0, that is whenever x equal to n pi. In that case the domain will be the set of real number minus n pi, where what is n pi? Pi, 2 pi, 3 pi, like that. Is it fine? So that is what is called as domain. Now what is the range? Range is the set of all possible values of the dependent variable. So range is related to my dependent variable. Okay. Suppose I am talking about the function y is equal to sin x. Then we know the sine value can always oscillate between minus 1 and plus 1. It cannot go beyond that. So the range will be minus 1 to 1. This square bracket indicates closed interval. Closed interval means that the end values are also included, that is minus 1 and 1 are also included. If you show the round braces, that is like this, then that means all values between minus 1 and 1 but excluding minus 1 and 1. Okay, you can have all the possible values, that is I can have minus 0.99956769 but not minus 1. Any possible value between minus 1 and 1 but not the boundary points. So what will this indicate? This indicates all the possible values between minus 1 and 1 excluding 1 but including minus 1. So square bracket always indicates closed interval and open bracket or the round bracket indicates open interval. Okay. So now you have got a feeling of what is the domain and the range. So what is domain? All possible values of an independent variable for which a function is defined. Range, all the possible values of the dependent variable. Now let us study what are the different type of functions. Basically we categorize function into two categories, one and many one. So one of the characteristics of a function is that it gives unique output for unique input. Okay. That is, if you give 1 as an input to a function, then it will result, let us say 2. Then it cannot happen that again if you give 1, you will be getting a value 3. If any time you give some input, you will get a fixed output. That is, for a unique input, we have a unique output. Which means, one-to-many relationship is not possible. That is, one input can never lead to multiple output. One input can always only lead to one output. Okay. So remember, whenever you see one-to-many relationship, then it is not possible. That is, if I give you a mapping like this, 1, 2, 3, 4, 5 like this, then it is not a function. Why is it not a function? Because this value 1 is mapped to two values 3 and 4. Then what can be a function for which we have a unique output for unique input? That is, there are two categories, one-to-one and many-to-one. One-to-one means every output is associated with one input. Okay. An output cannot be associated with the two inputs. That is a mapping like this. Let me say 10, 40, 30. Okay. Any output or any element in the range is only associated with one element in the domain. That is known as one-to-one function. What is meant by many-to-one? That is, suppose I give you a mapping like this, then it is known as many-to-one. Okay, do not think that it is not a function. It will not be a function if one input is mapped to multiple outputs. But multiple inputs can be mapped to a single output. It will still remain a function. Like I took an example, y is equal to x square. Actually, minus 2 square is also equal to 4 and 2 square is also equal to 4. That is, for two inputs x equal to 2 and x equal to minus 2, I am getting the same output, that is 4. So such kind of functions are known as many-one function. Okay. Suppose if we have y is equal to x, then it is a one-to-one function. As for one input, we can only have, or one output is only mapped to one of the input. So these are the two basic classifications of any function. Now let us see some of the categories of the function or special type of function. The first is even and the odd function. Now what are the even functions? Even functions are those whose graph is symmetrical about y-axis. When you draw the graph must be symmetrical about y-axis. Let us take an example. Y is equal to cos of x. If you see the graph of y equal to cos x, it is like this. So as you can see, about y-axis, it is a mirror image on the right hand and the left hand side. In terms of function, we will represent it like this: f of x equal to f of minus x. That is, if x is replaced by minus x, the function value remains the same. Similarly, if you take y is equal to x square, then x square is basically same as minus x square. Sorry, minus x whole square, because minus 1 square is equal to 1. Is it fine? That means it is also a even function that can also be observed from the graph. Its graph is like this. So graph on the left hand and the right hand side of the y-axis is symmetrical. Whereas suppose I shift this function x minus 3 square, then basically this graph is shifted to x equal to 3. Now it is no longer a even function. Is it fine? Because x minus 3 square is not equal to minus x minus 3 square, because this will become x plus 3 square. So that is what is meant by even function. Then what is meant by odd function? Odd functions are those which are symmetrical in the first and the third quadrant, or you can say symmetrical about origin. Such sort of functions are known as odd functions. Like, let me take an example. Y is equal to sin x. If you see the curve of y is equal to sin x, it is like this. Now if you see, the value to the left of y-axis is exactly negative of the value at the right. Such kind of functions are known as odd functions. So here the condition is f of minus x is actually equal to minus f of x. That is, the negative x-axis, the values on the negative axis will be negative of the values on the positive axis. Okay. Let us take another example. Suppose we take example of x cube. Then minus x whole cube will be equal to minus 1 cube. X cube minus 1 whole cube is minus x cube. So f of x is equal to minus f of minus x. So that is also odd function, which is evident from the graph. The graph of x cube is like this. Now as you see, it is symmetrical in the first and the third quadrant. Similarly, if any graph is symmetrical in the second and the fourth quadrant, like y is equal to minus x, it is symmetrical in the second and the fourth quadrant, then also it is a odd function. Okay. Whereas some functions can be neither odd nor even, like y is equal to x minus 3 square. It was neither symmetrical about the y-axis nor it was symmetrical about the origin. So remember, if you are given the mathematical form of a function, that is a formula, you can check by applying the condition f of minus x. If it turns out to be f of x, it is a even function. If it turns out to be negative of f of x, then it is a odd function. Otherwise, if you are given a graph, then you can check the symmetry about y-axis. If it is symmetrical about y-axis, even function. If it is symmetrical about origin, then it is a odd function. The next category of the functions is periodic function. Now what is periodic function? The function whose value keeps on repeating. How? Again, let us take an example of sin x. If you see the graph of the function, it is like this. So after this much time, you can see the same copy of the function is repeating. This interval is 2 pi. So the time after which it repeats is known as the time period of the function. Okay. And all periodic function are many one. Why? Because if you see, same output is coming for multiple inputs. So it is a many to one type of function. And what is the condition? That f of x plus t is equal to f of x, where t is the time period. Even if you take the condition, you can also write it as x plus n into t is equal to f of x, where n is any integer. Is it fine? But for n is equal to 1, this t is known as the fundamental period. Like for sine graph, it is equal to 2 pi. Is it fine? So such kind of functions are known as periodic function, and if the value does not repeat itself over time, then it will be aperiodic function. The function which are not periodic is aperiodic. Like y is equal to x. Its value goes on increasing and increasing, then that is why it is not a periodic function. Okay. Moving forward, let us see some different type of function. The first one is modulus function. It is represented like this: y is equal to mod of x. Now what is the significance of modulus function? It always returns the magnitude of number. Okay, what is meant by magnitude? That is, it will remove the sign. The mod of minus 2 is 2. Mod of 5 is 5. It does not care about the sign. It just returns the numeric value. Due to which, suppose if I am taking minus 2 mod, it is coming out to be 2. I can say it is equal to minus into minus 2. That is, if x is less than 0, if you are taking a number less than 0, then y will be equal to minus x. It will return the negative of a number, because negative of a negative number will be positive. But if x is already greater than 0, it will return the same number, because mod of 5 is 5. Due to this, the graph of the modulus function is, when x is greater than 0, then it will be y is equal to x. When x is less than 0, it will be y is equal to minus x, like this. Okay. So what is the domain of this function? The domain is minus infinity to plus infinity. What about the range? As you can see, modulus function can never return a negative value. The range is 0 to infinity. Remember, you will always show an open braces towards infinity, because infinity is not defined, so it will always be open braces, that is, it cannot be included in the interval. Is it fine? As you can see, it is also a many to one function, because mod of minus 2 will be same as mod of 2. The next function that we are interested in is known as greatest integer function. As the name suggests, greatest integer. So it results, or it gives me the greatest integer, which is just less than the given value. Suppose I give you 2.5. What is the biggest integer that is less than this? It will be 2. What about 1.97? What is the biggest integer that is less than this? It will be 1. Suppose it is minus 3.75. What is the greatest integer that is less than this? That is minus 4. That is, I want the integer should be less than this, but among all the integers which are less than this value, it must have the highest value. Because even minus 5, minus 6, minus 7 are less than minus 3.75. But among them, the highest is the minus 4. Now, that is why, how you will have this function, if there is any value of x lying between 0 and 1, then what it will return? 0, because it will return an integer which is less than this value. What about 1 to 2? It will return 1. Then 2 to 3, it will return 2, like this. It will return the integer which is just less than the number, and it is highest among all the integers. So the graph of the greatest integer function will look like, from 0 to 1 it will be 0. Why I am showing a circle here? This circle indicates that this is not included. From 1 to 2 it will be 1. Then 2 to 3 it will be 2. Then 3 to 4 it will be 3. Okay, here there is no circle actually. It is like this. Okay, from 0 to minus 1, that is minus 0.5. You want an integer that is less than that value, which is minus 1. So it will be like this. Then from minus 2 to minus 1, it will be minus 2. So actually, it is like a staircase function, as the graph looks like a staircase. That is what is meant by greatest integer function. It is represented in the square brackets like this. Okay. So remember, it will result in an integer which is just less than my given value. The next function is least integer function, which is just the opposite of the greatest integer function. So it will give me an integer value which is higher than the given number, but still it is least among all the possible integers. That is, if I give you x equal to 2.5, then the integers which are higher than this is 3, 4, 5, 6, but we need the integer which is least among them. So it will be 3. What about minus 1.95? Then we need an integer which is higher than this, that is minus 1, 0, 1, 2, 3, which is the least among them, that is minus 1. So it is represented something like this. So if the value is lying between 0 and 1, what will be the value? It will be 1. If the value is lying between 1 and 2, it will come out to be 2. If the value is lying between 2 and 3, it will come out to be 3. So how will the graph look like? It will look something like this. That is 1, open braces at 0. Because if it is 0, you need an integer that is higher than that, that is 1. Then from 1 to 2, it will be like this, 2. Then 2 to 3, it will be like this. Then like this. Okay. So this graph will be like this. This round braces or this circles represent wherever the value is not included. Is it fine? So that is how you represent a least integer function. Next we move on to the fractional part. Fractional part is represented by the curly braces. It is equal to x minus GIF of x. That is, we are subtracting the integer part of a number, then we will get the fractional part. Suppose I give you a number 2.5. Here the integer part is 2 and the fractional part is 0.5. That is, what I can do is, I can write it like this, 2.5 minus GIF of 2.5, that is 2.5 minus 2, which is 0.5. Okay. So how the graph will look like? Suppose I substitute 0 here, the GIF will also be 0. 0 minus 0 will be 0. As you move higher than 0 but less than 1, that is, if I am lying between 0 and 1, then what will happen? Between 0 and 1, the GIF will remain 0, but x will be represented as x. So graph will be like this. But as soon as you have 1, x is also 1, the GIF will also become 1, and you will again be back at 0. Then if you are lying between 1 and 2, then it will be equal to x minus 1. The graph of x minus 1 is like this. Okay. Again you will repeat like this. Because the fractional part can never go greater than 1. Since you are talking about the decimal part will always be less than 1. As you can see from the graph, it is a periodic function with period equal to 1. Is it fine? So that is how you represent the fractional part of any function. Then we move on to the signum function. Signum function is represented like this. Signum x, it is actually mod x upon x. Now as I told you, if x is less than 0, mod x is equal to minus x. Then that means signum x will be equal to minus 1. If x is greater than 0, mod x is actually equal to x. Then signum x is actually equal to 1. Due to which the graph will be like this. Okay, for positive values we will have plus 1, and for negative values we will have minus 1. Its value at 0 will be undefined. Why? Because 0 by 0 is not defined. So let me summarize what we have covered in this lecture. First I told you what is meant by function. Then we talked about domain and range of a function. Okay. Then we talked about odd and even function. Then we talked about periodic functions which repeat after a certain time interval. Then we talked about some special type of function like modulus function, like GIF and LIF functions. Then we talked about fractional part. And at last we saw the signum function. So these functions are commonly encountered in the examination, and sometimes it may puzzle you. That is why it is very necessary that you keep their definition in mind quite well. Okay. In the next lecture we will see certain operations that we can perform on the functions.